Hello everyone. Today I'm going to talk about a project that I have done for the course Machine Learning for Product Managers. So basically in this we will talk about first the project objective, then the approach, the different models that I have evaluated, and finally the conclusion where I will take you through the final model which I selected and the results. So in this project, we will build a model to predict the electrical energy output of a combined cycle power plant. We have 9568 hourly average ambient environmental readings from the plant. So these readings consist of temperature, ambient pressure, relative humidity, exhaust vacuum, and corresponding to each of these each of these hourly readings, we have a net hourly energy output from the plant. Now this is what we are trying to predict. So the approach here was firstly to identify the features and the target variable. The features here are temperature, exhaust vacuum, ambient pressure, and relative humidity. And the target variable that we are trying to predict is the net hourly electrical energy output. Step two was basically taking the data which was provided, splitting it into training data and testing data. So I identified 80% of the data to be used to train the model and 20% to test the model which is generated. Step three after that was to choose the different models that we need to build. So I have chosen a linear regression and a random forest. Linear regression is a straightforward model that establishes linear relationship between the features and the target, whereas random forest is a more complex ensemble model that can capture non-linear relationships in data. Step four was to actually build the models and test them out. So for linear regression, the model was built in a spreadsheet. And for random forest, I wrote a Colab notebook, which was written using Pandas library and scikit-learn. I will take you through that. Then finally, after I wrote both the models and I tested them, I compared the results from both the models. The root mean square error was calculated for both the models, and that was basically used to kind of compare the models. The model with the least root mean square error is a better model. And finally, after comparison, I found out that random forest model had a much lower root mean square error of about 3.36 compared to linear regression model, which had about 4.66. So therefore, random forest is a better model for performing this task. And then finally, I wrote one more Colab notebook to kind of use the random forest model and to predict the target variable for any combination of input parameters. So now let me take you through the two models that I have built. So for linear regression, so I took the full data, like I explained. So I took the full data and split it into training data and test data. So training data was 80%. I have written the linnest function in spreadsheet to kind of so that uses the linear regression model for this training data, and it generates the coefficients for the input parameters. So it generated the coefficients for each of the input parameters along with the intercept. So that is mentioned here. Now next I use this to calculate the the predicted power output for the test data. So I use the coefficients calculated for each parameter, multiplied it with the actual value, summed it up and added the intercept. That gave me the predicted power output. Then I found out the squared error, which was the difference between the predicted output and the actual output and the predicted output. And and then I found out the mean squared error. So mean squared error is the sum of the squared error. And finally, I found the root mean. So mean square error, sorry, is the average of the squared error. And then finally, I found the root mean squared error, which is basically taking the mean squared error and then finding out the square root of that. So to summarize, I found out the squared error, which is basically the delta between the actual output and the predicted output. Square of that, I found it for each of the input hourly values. Then I took the average of that to find out the MSE, and then I found out the square root of that to find out the RMSE. For the other model, for the random forest, I wrote the Colab notebook, so which using pandas and using scikit-learn, and using the random forest from scikit-learn. So I have loaded the training data and test data. I split it into two separate files, which I provided to the Colab notebook, and I built the model to use the training data. And then finally, that model was run for the test data, as you can see. And then I found out the mean squared error and the root mean squared error. So similar approach to their linear regression of finding the mean squared error and the root mean squared error. So finally, I found that the root mean square error for this model, for the random forest model, was about 3.36, whereas the root mean square error for the linear regression model was 4.66. So this means that the random forest is a much better model in this scenario. So finally, I built another Colab notebook using the same random forest model, where you could pass the values of each of the parameters, and it would predict the energy output. So as you can see here, I'm passing these 4 variables, and based on this combination of ambient temperature, vacuum, pressure, and relative humidity, it's predicting the energy output as 440.13 megawatt. So to conclude, I have found out that the random forest is a much better model in this scenario, and I've used that and built a notebook which could predict the energy output for any combination of the input variables. That concludes my presentation. Thank you so much.